Whenever I think about having a nice meal, I think about munching on a burger, pizza, or having some ice cream. But did you know that there are over 3 million individuals in the United States that do not have the luxury of eating comfort foods like we do because they suffer from a condition known as inflammatory bowel disease, also known as IBD. IBD is a group of diseases that occur due to a weakened immune system that cause inflammation in the intestines and lead to severe pain. Now, the associated medical costs with the disease is estimated to be over $18 billion annually. However, this is not the true price of the disease, as individuals with the condition have a reduced quality of life. The condition often hinders their career aspirations, and they have to face the social stigma that is associated with their restricted diet. Now, one possible method of treatment is to genetically modify bacteria to have a therapeutic effect and place it inside the patient's intestine where the inflammation occurs. Now, when I tell patients that I'm modifying bacteria that will be placed inside their intestines, they look at me like I'm trying to start the next pandemic. Now, that response is quite fair, to be honest, because bacteria does have a bad reputation, but it actually does more good than it does harm. Did you know that there are 10 times more bacterial cells inside the human body than human cells itself? Now, imagine that the bacteria is like a car and the DNA is the engine. To modify bacteria, I need to change the engine, which requires a sophisticated tool. This tool is what I have developed for my thesis. I've developed a device that uses a small electric shock that pops open the hood of bacteria so that the DNA can enter. Once the DNA is inside, it can produce therapeutic molecules. Now, the challenge is that there are millions of DNA sequences that can be used to modify bacteria, but we need to find out which one has the best therapeutic response. There is technology available to modify bacteria, but it screens DNA sequences in a very slow and expensive manner. On the other hand, my device is 100 times cheaper than currently available technology and can accommodate larger volumes of bacterial cells. As a result, I can process hundreds of DNA sequences in a single run, which results in a rapid screening process of DNA sequences. To provide some perspective, currently available technology can only process a single DNA sequence in a single run. To conclude, I've developed a cheap and highly efficient tool that can be used to insert several different DNA sequences into bacteria, which can then be screened to evaluate which one has the best therapeutic response in IBD patients. I hope that the day is not too far where everyone can enjoy a bowl of ice cream in peace. Thank you.